Alrighty. If log p base r is equal to log 2 base r is equal to 3 log q base r, use the law of logarithms to express p in terms of q. Did I cut off part of the question? Is it q and r or just q? Q. Alright. This isn't so bad. They all have the same base, don't they? Are we cool with that? If they all have the same base, it's not a big deal. So I'm going to use the multiplication law here. I'm going to bring the 3 to the front, and what's that do? What's that do? Log q cubed base r, and then use the multiplication law. So what's 2 multiplied by q cubed? 2q cubed base r. And what can you say about p then? P has to equal 2q cubed. Are we okay with that? Alright. Who got it out? Right, that's not so bad. Alright, 21. Alright, 21 is, yeah, if log, I did 21 yesterday. You can catch it on the video. Alright, what's the next one? Did I give you 22? No. Alright. Go for 23 now. Alright, 23 is... Alright. I'm going to use, for question 23, I'm going to use the multiplication rule. Why am I allowed to use the multiplication rule? Same base and addition, correct? So what's x times x minus 2? X squared minus 2x, okay? Now, for the 10th time, anybody tell me how to move these around? Yellow equals what? Yellow equals blue to the power of green. It doesn't matter what's there. And then, anybody got this one? Alright, this is where we're starting to get a bit thinner now. X equals minus 2 and x equals 4. Is minus 2 a reasonable answer? Why? If I go back to the original question, everybody see the original question? What happens if I enter in log base 2 and minus 2? What will happen? It's a maths error. Are we cool with that? There is no power of 2 that will result in an answer of minus 2. This won't happen. 2 to the power of 0 is 1. 2 to the power of minus 1 is a half. 2 to the power of minus 2 is a quarter. So it just can't happen. Okay? Alright, what's the next one you want done? 25? Alright. In 25, do they all have the same base? What base do they have? There is no base. What does that mean? It's automatically 10. So what can I do? It's subtraction. So what can I do with subtraction? So log 2x over x minus 7 equals log 3. What does that mean? 2x over 7 equals 3. Because they both have the same log on each side. Okay, so this is we did 23, now I'm doing 25, did 20. Now, multiply it over. 2x equals 3x minus 21. Bring 21 over the other sides. 3x take away 2x equals 21. X equals 21. Okay with that? Let's check your answer. I'm going to go all the way to the start. I'm going to do log 42. Because 2 times 21 is 42. Log 42. Minus log, what's it? 21 take away 7 is log 14. That answer is 0.477. And then what's log 3? 0.477. Same answer on both sides. Well, good. Okay, 28. 28 you want to? Yeah, 28. Alright, 28 is slightly different. 28 is pretty much done for you already. Alright. Once again, it's green, that's yellow, that's blue. What's the answer? Yellow equals blue to the power of green. What is 10 to the power 0? 1. X squared minus 4x minus 11 equals 1. Then the answer after that? X squared minus 4x minus 12 equals 0. Then after that, x minus 6 and x plus 2 equals 0. X equals 6 or x equals minus 2. Look at back up at the original question. Is minus 2 feasible? Let's find out. Minus 2 squared is 4. Minus 4 times minus 2? Huh? So you have to test out both of them. Minus 4 times minus 2 is plus 8. Take away 11. What's 12 take away 11? 1. Is log 1 0? Yes, it is. Minus 2 is a feasible answer. Let's see if 6 is a feasible answer. Does 6 work? Very unusual that 2 of them work. 6 squared? 36. 4 times 6? 24. Take away 11 is plus 1. Is log 1 equal to 0? Yes. In this case, both answers are okay. You do have to check though. You have to go in, plug it back into the original equation and see if it works. In this case, minus 2 worked because it didn't affect the overall value as much as you think. So when you plugged in minus 2 into this blue part here, it still came out as a plus 1, so it didn't affect it. Okay? So that's 28 done as well. So that's 20, 23, 25, 28. What did I give you next? Did I give you 29? No 29? Alright. 29, it's not on your own. Now 30. 30. Alright guys, for question 30, what did we do the last time? What did we do? They have the same base, so what does that mean? Same base means we're allowed to use the addition rule. So what's the addition rule? xy base 6 equals 1. What's the next part? xy on its own equals 6 over 1, and then x will equal 6 over y. We cool with that? Now, what do we know about this part here? What's that the same as? Same thing, isn't it? It's going to be equal to, it's exactly the same equation we started off with. It's exactly the same as this one here. So you can just change that into xy equals 6. Does that make sense? Now what do I need to get on its own? Substitution, so either x or y. Suppose I get x on its own. X equals 6 over y. What do I do here daily? Sorry, just give me a sec. Sorry, just to be a stickler. We always do the linear into the quadratic, don't we? So I'm not going to do that. Just the question has me slightly confused on my methods. I never do that. I always do linear into quadratic. I'm going to stick to what I know. In this case, I'm going to do y equals 17 minus 5x. Everybody cool with that? And what can I do up here? Sub it in, so what do we get? Yeah, I don't know why you'd want to change that up. You really wouldn't. 17x minus 5x squared equals 6. 5x squared minus 17x plus 6 equals 0. I'll see if we can do it your way. What do you reckon? Minus 3 and minus 2. Then we get 5x equals 2. X equals 2 or 5. X equals 3. I should go back up and just make sure none of them can be disqualified. So I'm just going to look back up at the original question. They're both positive. There's no reason why either one of them can't work, because they're both positive numbers, aren't they? Both values of x work. However, I haven't got the two y values yet, have I? Maybe one of the y values will be negative. So I need to figure that out now. So let's find out. Y equals 17 minus 5 times whatever this is. So 5 times 2 over 5 and 5 times 3. Y will equal 2 and y will equal 15. All the answers are positive, aren't they? Both y values are positive and both x values are positive, which means all those answers are acceptable. Good? Alright, let's move on. I am going to do 31. 31 is probably the most difficult one in the batch. Okay. Now, I'm actually going to do 31 two different ways. One way is considerably harder than the other, but there's no way you guys will know the difference yet. So let's do it two ways, and I'll explain why that happens. Okay. In fact, did anybody get this one out? Who? Fair play. All right. Now, here's your choice. Okay. You can keep x as the base or the number as the base. From my experience, what I remember is you don't want the letter being the base. So any ideas how to change that? Change log 2 base x into what? Log 2 base 2 over log x base 2. And what happens to 2 base 2? Turns to 1. 1, sorry, there's a 4 there as well, isn't there? Over log, yeah, x base 2. Now, some of you are probably going, well, that doesn't really help. Pick a letter. Also pick y, will we? What can I say y equals? Log x base 2. So what do we get here? 4 times 1 over y minus y minus 3. Now give y as a common denominator, then what happens? We'll end up with 4 minus y squared minus 0. We'll end up with y squared plus 3y minus 4 equals 0. We'll then end up with what? Y plus 4 and y minus 1 equals 0. And then what are our two answers? Y equals minus 4 and y equals 1. Right? Were you asked to solve an equation for y, or were you asked to solve an equation for x? Which one was it? X. So I haven't done what I was told to do, have I? So what can I do here? And then the next part. Now what you do now? X equals 2 to the power minus 4 and x equals 2 to the power of 1. Alright, and then the answer is x equals 1 over 16 or x equals 2. How many people did it with x on the base? Well, I've told you it can be done, but you really don't want to see me do it. Would that be enough for you just to memorize off using real numbers for the base and letters for the other number? We'll take a vote. Once again, you have a choice. You can use base 4 or you can use base x. Option A or option B. Which one are you going to take? Oh, you're grand. The one with the real number on the base. Sorry. Here, I'll make it bigger. You see it now? Alright. Option A was base 4. Option B was base x. For God's sake, pick option A. Okay? You don't want to do it. I don't want to correct it. It's win-win. Okay? Now, what can I change log 4 base x into? Log 4 base 4 divided by log x base 4. And what's 4 base 4? 1. So 2 log 4 base x plus 1 equals log 1 over log x base 4. Alrighty. What should I change the two of these into? A letter of your choosing. We'll go for y again. 2y plus 1 equals 1 over y. We go with that? Now, common denominator. 2y squared plus 1y equals 1. I think this has give me a sec. Yeah, I don't see a mistake, so I think I'm good. Anybody else get the same thing? Yeah? Alright. Actually, sorry, I'm right. There is no mistake. Never mind. Don't be so negative. We're cool with that. Y equals minus 1 and y equals half. What do I need to change that to then? Log x base 4 equals a half and log x base 4 equals minus 1. Now what do I do, lads? Times to the 4. X equals 4 to the power of half, which is 2. And x equals 4 to the power of minus 1, which is